Topic is divide and conquer. Divide and conquer is a strategy to solve problem, approach for solving a problem. Just like divide and conquer, there are other approaches also: greedy method, dynamic programming, branch and bound, backtracking, and they are suitable for different category of problem. So if you have any problem, then you should know using which strategy this can be solved, and you can follow that strategy for solving it. So first you should understand the strategy. Then once you practice few problems under this strategy, then you can solve the problems. So let us see what is the strategy. Divide and conquer strategy says that if a problem is given to you and you have to find a solution, but the problem is large, you cannot solve it. Large in the sense what? Large in the sense of complexity. There are many things involved in that you have to take care. Complexity of a problem? No. The size of a problem. Number of input. If 10 numbers are given to you, 10,000 numbers are given, 10 million numbers are given. So it is based on the size of input. So problem is large if the size of the input is large. Then what to do? Let us see. Divide and conquer strategy says that divide the problem into sub-problems. Sub-problems P1, P2, P3 goes on to some K sub-problems. Right? 2 or more sub-problems. Minimum 2. Right? It cannot be one. One means it is the same problem only. So actual problem, split it into 2 parts or 3 parts or 4 parts or 10 parts, whatever it is, K parts. Any number of parts. Then solve each individual problem. Get the solution for each. Solution for each. So each sub-problem is solved. Then combine these sub-problems, solutions of those sub-problems, to get the solution for main problem. Combine the solutions to get the solution for main problem. So here you should be able to know how to divide it and solve it, and then how to combine also, how to combine it. So if this can be done on any problem for solving it, then you can follow divide and conquer strategy. For solving a problem, if this can be followed, then you can follow divide and conquer strategy. Then, what if the problem, sub-problem is also large? Then, on the sub-problem also, you apply divide and conquer strategy. If the sub-problem is large, then on that also you apply divide and conquer strategy. So it means on this, division is done. This is also large, again division is done. This is also large, again division is done. That is also large, division is done. Then where to stop? This is small, stop. So you should also know what does it mean by small problem. So in divide and conquer strategy, you must define small problem. When do you say problem is small? Right? You should define when do you say the problem is small. If it is not small, then it is large. Yes. So large means it can be as much large as possible. So we don't have upper limit on the large, but we can have lower limit that this is small. Okay. So when you have a divide and conquer strategy applying on some problem, then in that problem you must define what is a small problem. Then only, if it is not small, then it is large. So I repeat, you have to take down this one. Divide and conquer strategy. It says that if the problem is large, then split the problem into sub-problems, K sub-problems. Solve sub-problems, get their solutions. Combine the solutions of sub-problems to get the solution for main problem. Okay, I repeat, if a problem is given, then divide the problem into sub-problems, k sub-problems, solve the sub-problem and combine the solution of all sub-problem to get the solution for main problem. Next, if the sub-problem is large, then apply divide and conquer on that also. If the sub-problem is large, apply divide and conquer on the sub-problem also. So divide and conquer is applied recursively. Okay, this is also a point you have to write down. Then last point, fourth point is you must define what is a small problem. Okay, first one is this one. Second one, if it is large, then apply divide and conquer. Third point is divide and conquer is recursive. Fourth point is we must define a small problem. So take these 4 points and draw this diagram. So divide and conquer problems are solved recursively. What I have explained just now, let us write it algorithmically. Algorithm D and C, that is divide and conquer. A problem P is given. If it is small, then solve it using some solution. Else, divide P into sub-problems P1, P2, P3 to Pk. Then combine solution of divide and conquer of P1, comma, divide and conquer of P2, comma, divide and conquer of P3, comma, divide and conquer of Pk. Solve all sub-problems by applying divide and conquer again. So I already told you that it is recursive, and combine all their solutions. So take this. This is the general form of divide and conquer, or control abstraction of divide and conquer. Control abstraction. So what we have just now discussed in words, we have written it algorithmically. Copy this, control abstraction. What are the problems that comes under divide and conquer that we are going to study? And what are the problems that are there in academics also? And same problems that are asked in GATE also. So the questions are asked in GATE from these problems. So let us see what are these problems. Binary search, finding maximum and minimum, merge sort, quick sort. That's all. There is one more problem called Strasson's matrix multiplication. This is not there in GATE. Now, for GATE, these three are important for GATE. So take the list of the topics. Already I have discussed binary search. I told you already, right? I have discussed about binary search. I wrote both recursive and iterative versions. So I will not explain binary search now. But I'll start with binary search. Alright, we are going to learn these things, but before learning them, we should learn one more topic. So that topic I will start along with binary search, right? By using binary search, I will proceed with the topic and I will finish the topic. Then we'll come back and study merge sort and quick sort. These two things we will study. So with the help of binary search, we will start another topic, a part of divide and conquer only. So what is that? I will list here, okay, separately. Okay, don't take it as a sixth number. Just take one more thing, that is recurrence relations. Recurrence relation. This is the topic that we will start now. So I'll first explain you binary search little bit, right? Revision. Then from that we will start recurrence relations. Once we know this, we have this in our hand, then merge sort, quick sort, when we do analysis, that is easy. So let us come to the topic. We have understood what is divide and conquer. We are in the topic of divide and conquer, right? And the topics that we have to study, we already know. Now, I will write down a binary search algorithm. Algorithm or binary search, okay, which is taking low, high and key. If low is less than high, then only continue, right? If low is less than high, check if, okay, find out mid is low plus high by 2 and this is floor value. If A of mid is equal to key or key equal to A of mid, then return mid. If key is, I should have written key first, that's easy for reading, A of mid. So every time I'll write key. Key less than A of mid means key is on the left hand side. Then we will call again recursive binary search with return statement or bin SRCH I have written. Then it's on the left hand side. So low is as it is, then high will be changed to mid -1, and then the key is as it is. We have already written this code. Otherwise, return our binary search. Then this will be mid +1, and this is high as it is, and key is sent to it as parameter. End of this if. We will check for all these things if we have at least one element, right? Less than or equal to. So both low and high are at same place, means they are equal. They are pointing on the same place. Or else low is less than high. If suppose low has become greater than high, then element is not there. So return -1. This was binary search algorithm we have already seen. Okay, so you have to take it again. I will not explain how binary search works and all. Already we have finished that. Working I have finished. Now I am going to start recurrence-lation. This is there in front of us. Now watch it. I finished writing. Okay, complete it fast. Okay, finished. Now let us see. This is divide and conquer. Yes, divide and conquer. How? If a list of elements are given to us, this is low and this is high. It says that list is very big. Then try to find middle. Check if the key is there. If it is not there, if key is small, then check on the left hand side. So we have split the list into two. It's divided into two parts, isn't it? Either left side or right side. In this problem, we have to check either left or right, not both. But in rest of the problem, we have to do processing on both the sides. But in binary search, only one side is enough. So we have split the list into two halves, and then we are processing on the left hand side. Then again, we go in the middle and try to split the list here. If the element is found here, we stop. Otherwise, if it is greater, then we will check into this part. So that's how we are going on dividing the problem into a small problem, that is splitting it. So at one point we will stop. What is that? How many elements must be there? When you can say it's a small problem. If there is a single element, then you can say it's a small problem. So yes, in a single element also we are doing this. If there are no elements, then we are returning this -1. Right? If there are no elements, then we are returning -1. Alright, so when it is small, if there is a single element, then it's small, right? Then it is solved. Otherwise, if there are no elements, then it is -1. So this is following divide and conquer strategy. So it's not processing on both the sides. So in the coming algorithms, again I will explain you how it is following the divide and conquer strategy, and it will process on both the sides and get the results. Alright, now we want time complexity of this algorithm. What is the time complexity? How do you specify the time complexity? The time complexity of this algorithm, of a recursive algorithm, is given in the form of recurrence relation. Already I have explained that. How we write recurrence relation. We say that the time taken by this is Tn. Then what it is doing? Let us find out the time. This is 1, okay, 1. Then this condition is checked. This is 1, yes. If it is true, it is returned, no problem, right? Or else this condition is also checked, yes. Then either this is called or this is called, not both. Any one of them is called. So what is this? Whatever the size of the elements are given to it, it is splitting into half and calling half on this side, half on that side. So either this n/2 or this n/2. Out of these two, it will be calling only once. So T of n/2. Only one, any one. It will call only one. Either it will go on the left hand side or it will go on the right hand side. So any one it will call. Then what is the total time taken by this one? Tn by 2 plus 1, 2, 3. So Tn by 2 plus 3. This is what? The time of entire algorithm. So we are mentioning the time as what? Tn. This is the time complexity. Right? See, we got the time. So the time of a recursive function or algorithm is also in recursive function. The time is also a recursive function. Tn is defined in terms of Tn by 2. It is recursive. So the recursive algorithm time is also recursive. Now here I will write down. We write recurrence relation in general form like this. Tn is equals to A Tn by B plus big O of f of n. We write in this form. So let us write it. Tn. A is what? 1. Nothing is there. 1. So just write Tn by B is how much? 2 plus this is 3. We have to write big O of that. Big O of f of n. This is f of n, right? This is f of n. F of n. Then big O means what? It's constant. 1. We write 1. So this is the recurrence relation of binary search. This is the recurrence relation of binary search. Take that. I'll remove this because I need space. So finally it means we don't have to count all these and write. Just these are constant values, so write 1 only there. Write 1. That is the recurrence relation. So I'll write here Tn is equals to Tn by 2 plus 1 if n is greater than or equal to 1 or greater than 1. If n is equal to 1, there is only one element, then nothing, it is returning. Then let us say 0. Instead of 0, let us write 1. Time is constant. 1 means constant. That also we have to write asymptotic value. So it is 1. This is the recurrence relation. So in the recurrence relation also you have to mention when n is small, what is the time? When n is greater, what is the time? Greater than 1 or larger, what is the time? So for 1 we have taken this one, right? If n is greater than 1, then that is the answer. If n is less than 1, then so and so answer. Now, how to find the time taken by this one? We have to solve this recurrence relation. We will learn how to solve recurrence relation. So now the topic is recurrence relation. Topic is recurrence relation. Let us solve this. I will just solve this, then I will freshly start with the topic and I will show you various recurrence relation. So we'll spend some time on this one. This is an important topic. From this gate questions are asked, right? So just for starting this one, I have taken the time complexity of binary search. Then I will solve this one. So you know why we are doing this. Then I will show you various recurrence relations. So Let us solve this. How to solve? Tn is equals to Tn by 2 plus 1. This is given. First equation. Then, if I can know what is a Tn by 2, then I will substitute that here, then I get the answer, final answer. What is Tn by 2? Find out. If Tn is equals to Tn by 2 plus 1, then Tn by 2 will be what? When this is n, this is n by 2. When this is n by 2 means this is n by 2 square, n by 4 plus 1 as it is. In place of n, we have n by 2. So in place of n, put n by 2. Then by 2 is already there. So n by 2 square plus 1. Right? This is very important. This is very important. So I'll elaborate it. T n by 2 by 2 plus 1. So this is Tn by 2 is equals to T n by 2 square plus 1. This is important. If you understand this, then that is enough. Rest, you can easily follow this one. This is an important topic. Finished? Now, substitute Tn by 2 in equation 1. Follow this one. Don't copy this. Just wait. Okay? How you copy in your notes, it's up to you. Right? So that part is separately I have given. Then we are substituting Tn by 2 in this one. So it will be Tn is equals to T n by 2 square plus 1. Then plus 1. So at this place, I have written this one. Right? Tn by 2 n square, sorry, Tn by 2 square plus 1. I have written this. Okay, open this one. Tn is equals to Tn by 2 square plus, if you open this, this is 1 plus 1, that is 2. So this is the second equation. Then Tn is equals to, okay. Substitute Tn by 2 square in second equation. So this will be Tn is equals to Tn by, when this was n by 2, n by 2 was n square, then n by 2 square will be what? N by 2 cube, then plus one more 1, and already 2 is there, so we get a 3. So I don't have to explain this one. I got this one. Right? Let me finish this. Then same way if I continue. Now it was n by 2. I made it n by 2 square. Then I made it n by 2 cube. If I continue, here I write. How many times I should do it? See, this is induction method or back substitution method. We call it as induction method or back substitution method. Then if I go on doing it like this, then up to what I should do? I should continue for k time. So I will write it here. Then what it will be? Tn by 2 power k plus, see this was nothing, so we got 1. Then next we got 2 here. Next this is cube, so we got 3 here. So k, we get k here. So continued for k times. Listen carefully. I'll explain a little bit once again. I was having this equation first. Then I wanted this one. How to know this? I have worked out here. I have given you the idea how to know this. Then I have substituted that Tn by 2 powers 2 plus 1 here at this place. So I got this one. Then if I open this one, then this is 2. Then in this again I substituted, so we got n by 2 cube plus 3. Then if I continue, n by 2 power 4 plus 4, 5 plus 5, k plus k, till k we have reached. Okay, listen. This is a recurrence relation. Okay, very important. Listen carefully. This is a recurrence relation. We are going on substituting and trying to reduce and reduce and reduce up to what? This one. You know this. What is that? When n is equals to 1, then answer is 1. So this one you can solve through this one only. You can solve this one through this one because you know something small. So you put that small, then you can solve the larger one. Or larger one keep on reducing up to it becomes small. So what is small? When n is equal to 1, then it is small. So this n should be equal to 1. It means this Tn, sorry, this n should be equal to 1. Then we take that answer, right? So it should be T1. And we know the answer, that is 1. So listen, I substituted n by 2, so we got square, cube, 4, 5, k. Up to what I should reduce? It is becoming smaller, right? Up to what? Assume Tn by 2 power k is equals to T1. It has become T1. We have reduced up to some level so that we think that it has become equal to T1. So when it is equal to T1, therefore n by 2 power k is what? 1. Then and n is equals to 2 power k. Yes. Also k is equal to what? K is equal to what? Log n base 2. Yes, log n base 2. So this assumption is very important. We are assuming that we have reached till that smallest value 1. So this assumption. Now based on the assumption, we assume that this has become T1. Therefore Tn is equals to T1 plus what is the k? K is log n. Then what is the T1? T1 is what? 1. 1 plus log n. Therefore, Tn is equals to order of log n or theta of log n because it belongs to the same class theta. We know this. It belongs to this class theta of log n. So we got the answer. This is how we solve it. So take this one now. See, while copying, read everything thoroughly, understand and copy it. Right? Don't blindly copy it. If you blindly copy it, then again you cannot solve it. You have to solve the rest of them. So read it thoroughly. Once you understand, then solve. Copy it. topic is little lengthy. Let us do it quickly. So first we will talk about decreasing functions. Recurrence relation for decreasing function. So first I will take one algorithm, demo, which takes some parameter n, and if n is greater than 0, then it will perform some statement. Okay, then it will call itself for n minus 1 time. This is an algorithm. Now, how to find the time complexity of this one? See, this is recursive. It is calling itself again. When we call demo n, then again calling itself with demo n minus 1. So the topic is decreasing function, right? So let me solve this. This is a tn, and this is 1, and this is 1. It is a conditional statement, and it's not a loop, just a simple statement. Then what is this? Tn minus 1. Then what is the recurrence relation? Tn is equals to Tn minus 1 plus 1 plus 1, 2. So we don't write 2, we write it as 1, right? So we don't write it as 2, we write it as 1. Then what is the recurrence relation? Tn is equals to Tn minus 1 plus 1 for n greater than or equal to, greater than 0. If n is equal to 0, then there is nothing, constant. It's not doing anything, so don't say 0, say constant. Alright? That is the recurrence relation for this algorithm. Alright? That is the recurrence relation. Now if you observe, this is not n by something, it is n minus something. So we are calling it as decreasing function. So the reduction of n is done, reducing n by decreasing, right? By subtraction, So how to solve this one? I'll show you. Okay, copy this one. So, okay, you have taken this one. Now, let me solve this quickly. See, Tn is equals to Tn minus 1 plus 1. Then, what is the Tn minus 1? So, Tn minus 1 is what? Tn minus 2 plus 1. And this is plus 1. So, you know how we got this one, right? So, since Tn is equals to Tn minus 1 plus 1, then Tn minus 1 will be what? Tn minus 2 plus 1. Therefore, I have substituted this one here. So this, if I expand, Tn is equals to Tn minus 2 plus 1 plus 1, 2. Got it? So if this was the first equation, then after substitution, this I got the second equation. Then if I continue, then this will be Tn is equals to Tn minus 3 plus 3. Right, this is the third equation. Continue for k times. If I continue for k times, then this will be Tn is equals to Tn minus k plus k. So this is the fourth equation. Now this we have to stop here and say that this can be solved now, because we have to assume that this has become small. What is small? This is n equal to 0. So n equal to 0 is what? 1. So we assume n minus k is equals to 0. Therefore, n is equals to k. This is the assumption. N is equals to k. Then what is this? Tn is equals to T0 plus n is what? K is what? N. So this is 1 plus n. And this is theta of n.